Welcome to Next Gen Manufacturing. Today, we are diving deep into the world of advanced materials. We're going to pull back the curtain on the invisible secret that's making all the high-tech stuff around us way stronger, way lighter, and more innovative than ever before. So let's just start with a puzzle you've probably wondered about. You know how modern cars are just jam-packed with safety gear and really complex tech? But somehow, they're lighter and more efficient than the cars that came before them. How on earth is that possible? I mean, take a look at a modern dashboard. This is not just some simple piece of plastic anymore. No way. It's a super engineered component built for safety, for looks, and for a perfect fit. It's a perfect example of the kind of complexity we're talking about here. Or how about this? A bumper beam. It has one job, and one job only: to absorb a massive amount of force in a crash to keep you safe. To do that, it has to be unbelievably strong, right? But it can't add a ton of weight to the car. So, what's the secret sauce?
Well, the answer lies in what I like to call the hidden skeleton. Yep, it's this invisible structure that gives all these parts their incredible properties. So, let's pull back the curtain and see what's really going on.
All right, meet the hero of our story, the continuous filament glass mat. Now, the most important word here is continuous. This isn't like other materials made from a bunch of short, chopped-up fibers. No, this is a web of uncut, interwoven glass filaments. Just think of it like a super high-tech fabric that forms the strong, lightweight backbone for all these modern composites. Okay, so you've got this amazing roll of material. Now what? How do you turn a sheet of this stuff into a dashboard or a bumper? Well, it turns out there are two fundamental ways that manufacturers shape these mats into the high-performance parts we rely on every day. So on one side, you've got what's called pultrusion, and the name kind of says it all. The glass mat is literally pulled through a bath of liquid plastic, and then through a heated tool that shapes it into something like a beam or a rod. Then on the other side, you have injection methods. Here, they do the opposite. They put the mat inside a mold first, close it up, and then inject the plastic resin under high pressure to form the part. Now, both of those methods are great, but they hit a wall when it comes to mass production. I mean, think about it. If you need to make over 1,000 really complex dashboards a day, trying to stuff flat sheets into a mold one by one just isn't going to cut it. It's too slow and it's not precise enough. So how did the industry get around this? They solved it with a totally brilliant innovation called preforming. This is the absolute key step that connects a flat roll of material to a complex 3D part. And believe me, it was a complete game changer for high-volume manufacturing. I love this quote because it just nails the concept. The preform really is the skeleton of the part. Get this, before any liquid plastic is even in the room, manufacturers create a solid 3D shape out of the glass mat that perfectly matches the final product. It's this skeleton that guarantees every single part is a perfect clone. And the process for making this skeleton? It's surprisingly simple and incredibly fast. First, they just unroll the flat mat and cut it into the right shapes. Then, those layers get sent into an oven to make them soft and workable. Right after that, bam! They're put into a mold that stamps them into that final 3D shape and cools them down. And finally, the finished preform, our skeleton, is taken out and trimmed, all ready for the next step. And the whole process, from start to finish, how long do you think it takes? Get this. In some cases, as little as 40 seconds. That's it. 40 seconds. From a flat sheet to a complex 3D skeleton in under a minute. That is the kind of speed that makes mass production of these amazing parts possible. So, as you can imagine, this preforming process is a massive win. You get that insane productivity we just talked about with perfectly identical parts every single time. It's also a really clean process with basically zero pollution. And because it uses those continuous fibers, the parts are actually 10 to 15% stronger. To top it all off, the finished skeletons are so rigid and stable that they're super easy for robots to handle. So, we've seen the material and we've seen the process. Now let's tie it all together and look at the real-world impact of this next-gen manufacturing tech. This is the really cool part. Hey, remember that complex car dashboard from the beginning? Well, it's this preforming technology that allows a single manufacturer to crank out over 1,300 of them every single day. That kind of output for such a high-quality structural part would be totally impossible without this preform advantage. But the innovation doesn't stop there. It gets even better. By carefully lining up those glass filaments in a specific direction, engineers can create a material that is 2.5 times stronger than the standard mat. That's not a small improvement. That is a huge leap. It lets them design parts that are even lighter and tougher than before. And of course, this technology isn't just for car dashboards, not by a long shot. It's used to make all kinds of things, from aerodynamic truck cabs and structural floors for cars, all the way to translucent building panels and super strong industrial beams. The versatility is just incredible. So, there you have it. This hidden skeleton of continuous glass fiber is quietly making the world all around us stronger, lighter, and more efficient. It has already completely reshaped the auto industry. So the only real question left is, what are we going to build with it next?